Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on turbulent flow in pipes. In our previous lectures, already we have discussed a similar kind of problem when the flow is turbulent and it is flowing through a pipe, and the pipe may be smooth and rough pipe. So in our last lecture, we have solved a problem on rough pipe. So in this problem, let's see what need to be calculated. So here the question is given: determine the wall shearing stress in a pipe of diameter 100 millimeter carries water. The velocity at the pipe center and 30 mm from the pipe center are 2 meter per second and 1.5 meter per second respectively. The flow in pipe is given as turbulent. So there is a fluid flow is flowing through a pipe, and the flow type is turbulent type. So suppose this is a pipe is there, and the liquid or the fluid which is flowing through this pipe is turbulent. So you can give a flow arrow marks like this, and let's see, or let's consider this is the flow velocity u here, and which is flowing through this pipe, and the pipe diameter is given. This is 100 millimeter. So let's see what are the data given in this question. So this is about the pipe. Data given is determine the wall shearing stress. So first line itself, it is asked to calculate the shearing stress at the pipe. So this is the wall is there. That means the pipe surface is there. This is one wall. This is another one. So at this point, we need to calculate the wall shearing stress. So that means we can say we need to calculate the tau. And next, the pipe diameter is given, d is given. So d given, this is 100 millimeter, and which can be converted into meter. So that is 0.1 meter, and this can be written as 0.05 meter, that is equal to r. So this one we can write like this. So radius is 0.05 meter. Now the velocities at the pipe center. So velocity at the center pipe means this is the center line of this pipe. Now actually we know that the velocity when the fluid is flowing through a pipe, so at the surface of this wall the velocity is negligible, and which need to be considered as zero. And when you see the fluid is flowing, that means the velocity when it is coming away from this surface, so the velocity of this fluid is little bit increasing more. So that means we can get a maximum velocity at the center of the pipe. So the velocity at the pipe center is given 2 meter per second. So you can write this is v max, or you can write the u max if you consider a u. So that is given 2 meter per second. So velocity at the center, this is given 2 meter per second, because that is the maximum point. And 30 mm from the pipe center. So this is the pipe center is there. So from here again, just suppose consider 30 mm from this, the velocity is given here, u equal to, this is 1.5 meter per second. So you can write this is 1.5 meter. So again you can write u at 1.5, no, u at 30 mm actually, u at 30 mm distance from the center, that is 1.5 meter per second, and the flow type is turbulent type here. So now we need to calculate this tau. So to calculate this wall shearing stress, we need to go to the turbulent flow condition actually. That means we have derived already the equation for the velocity distribution for the turbulent flow in our previous video. If you have seen that one, you can understand, or we can identify that equation from that. So the velocity distribution for this turbulent flow in terms of that maximum velocity, because in that equation only you can get the maximum velocity, local velocity, as well as the shear velocity. So let me write this equation. That equation is nothing but u max minus u divided by u star equal to, this is 5.75 and this is log 10, this is r by y. Actually, this is the equation what we have derived in our previous video lecture. There we got this velocity distribution for the turbulent flow. Okay. Now here, if you see what are the data are available with us. Now u max is there. This is 2 meter per second, and this is the local velocity. You can see that u, or this velocity which is present at this all these zones. So that is 1.5 meter per second. So we can get it. This one we know, and this is also known. Now these things in this r value and y value which is there, that is r also we got, this is 0.05 radius is there. So y equal to here actually y the distance actually. So that one we can calculate how. Let y equal to, suppose this one we can write here, we can write what, yeah, r minus r. R minus r means what? Now, this is the total radius which is sorry, this is total diameter. So this half of this means this is 0.05 meter, and 30 mm from this from the center point of this. So that is again one more r. This one you can give capital R, and the small r you can write, this is 0.03. The 30 mm what is there, that we can write in terms of the small r. So y equal to actually what is the height of this from here. So you can write this is capital R minus small r. That means 0.05 minus 0. This is 0.3. So we'll get the value 0.02. This is meter. This is the value of y. So all these values are identified here. So you can find out the u star value here. So just put the value, all these things what we got. U max is nothing but 2 meter per second, and that velocity is there. This is 1.5 meter per second, and u star need to be calculated from here. And this is 5.75, and this is log 10 divided by r equal to here 0.05, and the y distance, this is 0.02. So all these values are given here, and just let take this u star this side, and remaining term let it to the denominator side. So what I'll do here, so this is 0. This is 0.5 actually, 0.5 by u star, and this is 5.75. Let's take this calculator help. So what we'll get here, that means 0.05, 2.5. So log of this 19.89 into 5.75. So this is 114. Actually 114.4 what we got here. Now this will get the u star value, which is 5.74. Okay, let's see. No, let it do it one more time. 0.05. So divided by this 0.05 divided by 0.02, and log of this log of 2.5. Same thing I did, I thought. Anyway, okay, into multiply of 5.75. Yeah, 2.288. So last time we got near about a 114 value. I was confused that how we got this much lengthy value here. So anyway, while calculating, we need to be careful in that. So 2.288. So this is all total what I can write here. So on behalf of this, I can write this, we got 2.288, and these things I can write u star equal to, very simple, this is 0.5 divided by 2.288. So again what I'll do is 0.5 divided by 0.288, 0.218. So this is nothing but 0.218 meter per second. So this is about the shear velocity. If you remember the U star term, this is shear velocity. Now our motto is we need to calculate the wall shear stress. Okay, the shear stress is nothing but tau, or near to the shearing stress means we used to consider the tau naught. The tau naught. Why? Because at the position of near to the wall, the y value is 0. That's why I used to call this is tau naught. So this U star, if you remember, there is another relation is there, that is U star equal to root over of this tau naught divided by rho. This is another one relation. While deriving the equation, we got this. Now what I'll do here, here tau is unknown, we need to calculate this. So rho is known, because rho is the density of the liquid which is flowing, that means water density. So now U star already have calculated. So what I'll do, I'll just remove this root over here. So what we can write, tau naught by rho, this is U star square, and this is tau naught equal to U star equal to how much? 0.218. So 0.218 into 0.185 equal to this multiply of this is rho value. So rho is nothing but 1047.74. So that means what I did here, U star square. So U star square is nothing but 0.218 square into rho value. Rho value is density of this water, so that is 1000. So finally what we got, the tau naught equal to 47.75. you can write 47.75. this is Newton per meter square. So this is all about this problem. So very simple actually, this problem. Only if you know the formula here, one is this velocity distribution formula, another one formula is this shear stress formula, shear velocity formula in terms of stress and density term will be there in that, and remaining all are very simple. Just we need to go with the indication what is given in this question. Very simple, we can solve it easily. So I hope you understand in this lecture. If you are having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.